Hey there, Andy here. So in this video I want to talk about some really important substituents and common functional groups that you are expected to know for the MCAT. So we're going to start out with some really common substituents. These are basically side chains that you see in a lot of organic molecules that you've, obviously come across in your study of OChem, in your lectures, in your college courses, but are important to cover nonetheless just to make sure that you have a solid understanding of them. So the first one we're going to talk about is CH3 substituent, which is the methyl group. Then we have CH2CH3, known as the ethyl group. We have C2C2CH3, known as the propyl group. So you can tell we're just adding one carbon to the chain, and we're going from methyl, what would have been if it weren't a substituent, methane, ethane, and propane, but since they are, they have the YL ending, so methyl, ethyl, and propyl. And then, since the propyl substituent is made of three hydrocarbons, they can actually be arranged in a different order, which gives you isopropyl. So isopropyl is when the substituent is bonded at the middle carbon instead of the first carbon. So this is isopropyl. And then we have butyl, CH2, 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 CH3. This is butyl, like butane, but with the YL substituent ending, or also known as N-butyl. And that N means normal, which basically means that it's straight chained. So it's bonded to this first carbon over here. So obviously, it doesn't have to be bonded to the first carbon. So if it's, say, bonded to the second carbon right here, it's called sec-butyl. Sec-butyl. So that's, a substituent of butane, so as the YL ending, and if it's bonded to the second carbon, sec is the prefix. And, it can also be bonded differently. So tert-butyl, tert-butyl, is if it's bonded like this. So more than likely you've come across these very basic substituents in your OChem classes, and I just wanted to double check that you guys got them, and not to be afraid when you see complicated molecules on the MCAT Orgo section that say tert butyl. You should at least be aware of the type of structure that it might be talking about. So those are the basic substituents you need to know. Perhaps more importantly is being aware of common functional groups. Functional groups. Common functional groups. The MCAT is very well known for throwing in a question or two about, identify this functional group, or in some cases, know how it reacts with different groups. So you should be at least aware of their names. So we're going to quickly go through some of the easier ones that you should already be familiar with, and then hit some of the less common ones that you've probably also seen in your studies, but just need a refresher. So obviously we start off with kind of the easy hydrocarbons, the easiest possible alkanes, where we just have two carbons single bonded to each other and three different groups coming off of each carbon. This is an alkane. Notice the A and E ending. Then we have alkenes with a double bond, alkene. Then we have alkynes, which is, oh, sorry, which are two carbons triple bonded to each other with one R group. And so alkene. And so those, mine the different endings. Ane for single bonds, ene for double bonds, and ine for triple bonds. Then we have some special functional groups. We have, let's change our color. We have alkyl halides, which is basically X is the halide group. So something like chlorine, bromine, iodine are halides. We have alcohols with this OH group. So this is just a simple alcohol. We have thiols, which is a sulfur group bonded to R chain and a hydrogen. So this is a thiol. Then we have ethers, which is an oxygen bonded to two different R groups. Ether. These R groups can be different. We have epoxides, which is you can think of as a closed ring with one of the vertices an oxygen. Oh, I'm sorry, I wrote this wrong. This should be double prime and this should be prime, and then these can be prime and double prime, so they can be different R groups. And this is an epoxide. And then we have phenols, which is basically, if you want to think about it, an alcohol on a benzene ring. So these are, we're getting there. We have a lot of different functional groups to discuss, and these are phenols. Oh. Phenol. Okay. Let's change our color. Then we have ketones, which are carbon double bonded to an oxygen with different R groups on each side. This is a ketone. Sorry, double prime, ketone. Then we have an aldehyde, where this is an R group, and then this is a hydrogen. Aldehyde. Then we have a carboxylic acid. Carboxylic acid. And so you can tell that these are all very similar. Ketone just has one of its R groups replaced by a hydrogen to get an aldehyde, and then a carboxylic acid just has that R group replaced by an OH. And from here we get our acetyl group, which is a central carbon bonded to two R groups that can be different, and an oxygen with an R group bonded to an R group that can be different, and another oxygen bonded to a hydrogen this time, so an alcohol. And so this is known as a hemiacetal. And notice, the wedge and the dashes. That means that there's a specific 3D orientation. So the wedge is coming out, and then the dash is going in to the page. And then we have a very similar molecule and oxygen, and then another R group that's different. And so this is acetyl. So a hemiacetal is just replacing one of these OR groups in an acetyl with an OH. We're getting there. We still got a couple more. We have an amine, which is a nitrogen bonded to three different R groups. And see, these dash and wedges mean that there is a 3D orientation. So this is an amine. Then we have an imine. So that's going to be a nitrogen double bonded to a carbon with two different R groups, and this nitrogen is also bonded to a hydrogen. And it has a lone pair of electrons, and this is an imine. So amine, imine. So you should know the difference. This is, this would be a great question because it's so uncommon for regular students to know. So that's an imine. And then we have our final set. We have an acid halide, where again X is an halide, so an acid halide. Then we have an acid anhydride. Whoops. An acid anhydride, which is somewhat similar. It's kind of like two acid halides without the halides. So that's an acid anhydride. Then we have an ester. This is an ester. And then we have an amide. Oh, that's an nitrogen. An amide. Okay, so those are the most common functional groups. I would highly recommend that you memorize them all. I tried putting them in color groups the way I like to think about them together, so that might help you. Be careful not to confuse things like amines with imines, or some people, confuse amide with amine or imine as well. So get those differences in your head, and be sure not to. I always do this. Confuse ester with ether right here. So watch out for those. And yeah, so be sure to memorize all these. Use flashcards, use whatever you need. But these are very important, basic things you need to be able to work with for the MCAT.